On Sephora's glossy shelves, every lipstick or shimmering powder seems like harmless beauty. But behind each one lies a high-stakes system of industrial chemistry, global sourcing, and safety checks that most shoppers never see. Sephora leads trends, but almost everything bearing their name is produced in outside factories, pulled together by a worldwide supply chain and only loosely guided by retailer-made standards such as clean at Sephora. If makeup can contain hidden impurities, minerals linked to child labor, or ingredients banned in one country but legal in another, what does really made even mean? And who is actually keeping your products safe? This is how Sephora's makeup is really made. Behind every compact or lipstick at Sephora sits a world that looks more like a science lab than a makeup counter. Modern cosmetics are built on industrial chemistry, where formulas are developed, tested, and produced at a scale that rivals pharmaceuticals. Each product starts as a set of demands: the right color, the right feel, the right performance, and a list of ingredients that must be included or strictly avoided. These demands are not just about beauty, they are about safety, global rules, and the pressure to keep up with trends that move faster every season. The journey from raw materials to finished makeup is anything but simple. Pigments may come from mines in Italy, oils from plantations in Asia, and packaging from factories in China. Ingredients pass through dozens of hands and countries, with each step bringing its own set of standards and risks. This is the reality of a global supply chain. A single batch of powder could involve minerals from 3 continents, processed and pressed in a factory thousands of miles from where it will be sold. The sheer distance between source and shelf means that quality and safety can never be taken for granted. Consumers are asking harder questions than ever. What is actually in this product? Who made it? And how do I know it is safe? Headlines about hidden impurities, banned substances, or the use of child labor in mineral sourcing have made shoppers more alert. Answers are not always clear. The word clean can mean something different depending on which retailer or brand is using it. At the center of all this is the question of control. How much does a retailer like Sephora really know about the formulas it sells? When a product is labeled clean at Sephora, does that guarantee safety or just compliance with a marketing standard? With manufacturing spread across the globe and oversight divided between brands, factories, and regulators, the line between marketing promise and scientific reality can blur. For shoppers, that means buying makeup is not just picking a favorite shade. It is a leap of trust into a system most never see. A system built on chemistry, contracts, and constant negotiation between what is possible, what is legal, and what is demanded by the next big trend. Sephora stands at the crossroads of beauty retail and global manufacturing. As a company owned by LVMH, it sells hundreds of brands and also runs its own private label, Sephora Collection. The products under this label do not come from a single factory or a lab. Instead, Sephora works with a network of contract manufacturers around the world. Specialist companies in Italy, France, Germany, the United States, and China, each chosen for their expertise in a particular formula or packaging technique. For a new lipstick or palette, Sephora's product development team creates a detailed brief, the desired color, texture, performance, and a list of ingredients that must be included or left out. That brief is sent to external labs and factories, which submit samples for review. The process is collaborative, with back-and-forth adjustments until the formula and packaging meet Sephora's standards. But Sephora does not own most of these factories. The company's control comes from contracts and technical standards, not direct daily oversight. Each manufacturer is responsible for following strict quality and safety protocols, like ISO 2271 schemes for good manufacturing practice, and must supply batch records, certificates of analysis, and ingredient disclosures for every production run. Sephora's own teams audit suppliers and may test incoming batches at distribution center. But the hands-on work of mixing, filling, and packaging usually happens outside Sephora's walls. Programs like Clean at Sephora and Planet Aware add another layer of requirements. These are not legal regulations, but retailer-created standards. For example, the Clean list bans ingredients such as parabens, phthalates, and certain sulfates, even if those ingredients are legal in the United States or Europe. Suppliers must certify that their formulas meet these criteria, and Sephora can require documentation or spot testing to verify compliance. Still, these standards are designed by Sephora's marketing and regulatory teams, not by government agencies, and their definitions can change as consumer preferences evolve. Ultimately, Sephora's power lies in its ability to set the rules for what appears on its shelves. Through product briefs, supplier contracts, and merchandising standards, the actual manufacturing, ingredient sourcing, and even some safety testing are handled by outside experts. This division of responsibilities means that while Sephora can demand high standards and transparency, the final product is always the result of negotiation and cooperation between retailer, manufacturer, and a global supply chain. Lipstick begins with a blend of waxes and oils, each chosen for melting point and for the way it feels on the lips. In a cosmetics lab, a chemist weighs and combines ingredients such as castor oil, carnauba wax, and shea butter, heating them until they become a clear molten base. Pigments like red iron oxides, titanium dioxide, and sometimes shimmering mica are then added, but not just tossed in. To avoid a gritty or streaky finish, pigments are milled on massive 3-roll mills, grinding them down to a fine, even particle size. Even a difference of a single micron can change how the color appears and how it wears. Once the pigment is perfectly dispersed, the mixture is poured into metal molds, cooled, and then gently released as solid sticks. Each batch is checked for color match, texture, and even how smoothly the bullet twists up and down in its case. Foundation follows a different path. The science here is all about emulsions, mixing oil and water phases that normally resist each other. Chemists first create 2 separate mixtures, a water phase that may include humectants such as glycerin, and an oil phase with emollients and sometimes silicone for slip. Emulsifiers are added to help these phases blend, and then the two are combined in a high shear mixer. These machines spin at thousands of revolutions per minute, breaking the oil into tiny droplets so the finished foundation feels smooth, not greasy or chalky. The mixture is then deaerated to remove air bubbles, ensuring a flawless pour into bottles or tubes. Quality checks focus on viscosity, meaning how thick or runny the foundation is, along with color accuracy and microbial safety. Quality is measured both by the chemist's eye and by instruments. Color is measured with a spectrophotometer, comparing each batch to a master standard. If the color is even slightly off, the batch may be rejected or adjusted with additional pigment. Stability tests follow, exposing samples to heat, cold and light to see if the formula separates, fades, or changes texture over time. Any sign of instability sends the formula back to the lab bench, sometimes for weeks of reformulation. These steps are not only about product performance, they are about meeting retailer requirements, regulatory limits, and the expectations of shoppers who want bold color, lasting wear, and comfort, all in one swipe or pump. Balancing the formula is a constant act. Every tweak, changing a wax, swapping a preservative, adjusting pigment load, can ripple through the process, affecting appearance, application, and shelf life. The finished lipstick or foundation is as much the product of industrial science as it is of artistry, ready to be pressed, filled, and shipped to stores around the world. Pressed powders and mascara look simple on the shelf, but their design is anything but straightforward. In a factory, the process for making a compact powder starts with a careful blend of pigments, fillers like talc or mica, and binders that hold everything together. The mix is sieved to remove lumps, then poured into metal pans. Here, pressure matters. Too little, and the powder crumbles at the first touch. Too much, and the surface turns rock hard, refusing to pick up on a brush. Manufacturers target a specific hardness measured in newtons to balance break strength with what chemists call payoff, how much color transfers with a single swipe. Talc and mica are not just fillers. Talc gives powders a silky feel and helps control oil, while mica adds a subtle shimmer or glow. Sourcing these minerals brings its own set of challenges. Factories require suppliers to provide certificates proving the talc is asbestos-free, often tested by both polarized light microscopy and transmission electron microscopy. Mica, prized for its sparkle, can be natural or synthetic. Synthetic mica, known as fluorphlogopite, costs more but guarantees purity and eliminates concerns about child labor found in some mining regions. Once the powder is pressed, it is checked for uniformity. Technicians test for pan adhesion. Does the powder stay put or pop out? And for dusting, which measures how much product kicks up when a brush hits the surface. Even the angle and pressure of the press are recorded in batch logs, since a tiny variation can mean the difference between a pallet that survives shipping and one that arrives shattered. Batch logs are part of traceability. MoCRA brings a different kind of engineering. The formula is a suspension of waxes, film formers, water, and pigments. Waxes like beeswax or carnauba build body and hold curl, while film formers help the MoCRA stick to lashes without smudging. But the real secret sits in the cap. The brush. Its design, length, density, fiber type, and even the spacing of bristles determine how much formula is deposited, whether lashes look separated or thick, and how well clumps are controlled. Brush design is as important as the formula. Some brushes use molded plastic spikes. Others rely on twisted wire bristles or hybrid constructions. Manufacturers test the formula and brush together, looking for clumping, flaking, and wear time. A MoCRA that passes in the lab might still fail in the real world if the brush does not deliver the right amount of product. For both powders and MoCRA, the journey from raw ingredients to finished product is measured in data points: press strength, payoff, viscosity, and clump factor. Every batch is a record of tiny adjustments. Pressure here, pigment load there, that add up to the difference between a product that sits on the shelf and one that becomes a bestseller. Gatekeeper. Inside a cosmetics factory, quality assurance is more than a checklist. It is the gatekeeper between raw chemistry and a product that can actually reach the shelf. Every batch starts its journey tracked by a unique lot code, with details logged in a batch record that must be kept for years. These records link every ingredient, every process step, and every test result to a specific run, creating a paper trail regulators can audit long after the makeup is sold. The heart of the process is a series of control points. Hygiene zones separate raw material storage, mixing, and filling lines to prevent contamination. Staff wear dedicated uniforms in each area, and sanitation logs are signed daily. Before production begins, operators verify that all equipment is cleaned and calibrated according to ISO 22716, the global standard for cosmetics manufacturing. This is not just best practice. It is a legal requirement in the European Union, and soon, in the United States under the Modernization of Cosmetics Regulation Act, called MoCRA. Real-time. During production, technicians monitor critical parameters in real time. For a foundation, viscosity is measured with a viscometer. If it is too thick or too thin, the batch cannot proceed. pH is checked, especially for products that touch the skin or the eyes. Color accuracy is measured with a spectrophotometer. The device compares the batch to a master standard, and if the color difference known as delta E is outside the allowed range, the entire lot is flagged. Microbial samples are pulled and sent to the laboratory, where plates are incubated to check for bacteria or mold. Each checkpoint is logged, and any deviation triggers an investigation. Final sign-off. The final hurdle is the release card. Only a quality assurance lead or a regulatory lead, never production staff, can sign off that all tests have passed and documentation is complete. Without that sign-off, a batch cannot leave the facility, no matter the deadline or the demand. In the European Union, Regulation 1223 of 2009 requires every product to have a designated responsible person who holds the product information file, including all safety assessments and test results. In the United States, MoCRA now mandates facility registration, product listing, and adverse event reporting, with new good manufacturing practice rules set to take effect by 2025. These overlapping systems are designed to catch problems before products reach a store, but they also create real pressure. A single failed test can mean a costly delay or the destruction of thousands of units. For every lipstick or powder that passes, there is a trail of data, and a quality assurance lead whose signature is the final word. A pressed powder or lipstick may look flawless, but the real test comes under the microscope. In the lab, each shipment of talc is sampled, sealed, and logged with meticulous care. Analysts begin with polarized light microscopy, searching for asbestiform fibers. If nothing turns up, transmission electron microscopy takes over, able to spot even a single asbestos fiber at parts per million levels. The PLM and TEM methods are standard for major brands, and the consequences are real. A contaminated batch means recalls, regulatory scrutiny, and lost trust. The FDA post-2021 talc survey found no detectable asbestos in cosmetic samples, but every lot is still checked, and certificates are issued batch by batch. Zero tolerance is not just a slogan, it is enforced, one shipment at a time. Heavy metals present a quieter threat. Pigments and minerals can carry traces of lead, arsenic, or cadmium, even when brands source carefully. Lipsticks are screened with SCP-X, a technique that detects lead below 2 parts per million. The FDA limit sits at 10 parts per million, but most lipsticks tested fall well under that limit, often less than 2 parts per million. If a batch comes close to the threshold, it is flagged, retested, and traced back through supplier records. One outlier can halt production and trigger a full investigation. Mica, the mineral responsible for shimmer, raises questions that science alone cannot answer. In mining regions like Jharkhand in India and southern Madagascar, children as young as 6 work in informal mica mines. The Responsible Mica Initiative tracks supply chains and funds local schools, but less than half of India's mica exports are fully audited. Some brands now use synthetic mica, fluorphlogopite, produced in controlled labs and free from child labor. The price is steep, up to 10 times higher, but the purity and consistency are unmatched. For premium and clean formulas, the switch is already underway. Each lab report decides the fate of thousands of products. The story of talc, pigments, and mica stretches from microscopes to mines, from chemistry to human cost, shaping what finally reaches the shelf. Every batch of Sephora collection makeup is released only after passing documented good manufacturing practice controls, including ISO 22716 standards and laboratory tests for color, pH, and impurities. Sephora operates as a global retailer and private label owner, relying on external contract manufacturers to make products that meet legal requirements and internal standards such as Clean at Sephora. While US law is evolving under MoCRA and the EU maintains detailed regulations such as Annex 2 of Regulation No. 1223 of 2009, ingredient and supply chain risks like heavy metals in pigments or labor abuses in mica mining persist across the industry. Not all sourcing or testing data is publicly disclosed, and some ingredient origins remain proprietary. Today, ongoing reforms, stricter testing, and consumer demand for transparency are shaping how makeup is made and sold. Documented controls can reduce risk, but the full story of every product often remains partly hidden behind supply chain complexity.